Assalamualaikum and a very good morning to Dr. Muhammad Khair. And today, me and my fellow members are going to present a group assignment and we are going to talk about the title will be Analysis of Simple Trusses. We are from group 7 and let's continue. So, this is the group members. We have Yogan, Shazri, which is me, Muhammad Shahmi, Muhammad Danish, and Marcelinus. Each of them will be introducing themselves when it comes to their part. Thank you.
A very good morning to my lecturer and my fellow friends. My name is R. Yogindran, son of R. Ravindran. My metric number is CD240383. Today, I would like to present about analysis of simple trusses. First of all, introduction. Statics is the branch of mechanics that studies forces acting on subjects at rest, ensuring equilibrium is maintained. A key application of statics is the analysis of stresses to structural frameworks made of straight members connected at joints, often forming triangular patterns for stability. Simple trusses are widely used in real-life structures such as bridges, roofs, and towers due to their strength and efficiency and ability to distribute forces evenly. This presentation focuses on analyzing simple trusses using methods like the method of joint and method of section, highlighting their principles and application in engineering. Literature review. The analysis of simple trusses is a fundamental topic in statics, which provides essential knowledge for mechanical and manufacturing engineering. The development of trusses analysis dates back to early 19th century with contributions from Augustine Louis Cauchy and James Clerk Maxwell. These pioneers of formalized methods for analyzing structure under various loading conditions, which laid the groundwork for modern structural analysis. Standard assumptions in truss analysis are pretty well discussed in the literature. There are four. First one is truss members are connected by frictionless pins. Second one is loads and reactions can be applied only at joints. Third one, members are subjected to purely axial forces, either in tension or compression. Fourth, the weight of members should be neglected unless otherwise stated. These assumptions simplify the mathematical modeling of trusses and thus allow for straightforward application of equilibrium equation. There are two methods, which is method of joints. Each joint is considered individually and then using the equilibrium equation, it seeks to determine forces in connected members. The method of joint is used basically for smaller trusses or finding the forces in all its members. The second method is method of section. This approach involves cutting the truss into sections and applying equilibrium equation to analyze specific members directly. It is efficient for analyzing large trusses or determining forces in a few members of interest. Due to the high strength to weight ratio, find wide application in mechanical and manufacturing engineering. Applications includes bridges, Pratt truss, and Warren truss are simple trusses commonly used. In manufacturing frameworks, the trusses that are lightweight and modular find usage in machine structures and robotic framework. The third is building roof. Trusses are structural elements that provide support to roof with minimal material usage. Analysis of simple trusses is a cornerstone in the education and practice of statics. Computation techniques are at the forefront of a development method of solution, including the method of joint and method of section. Future research will continue to be aimed at making trusses structures even more efficient, reliable, and materially sustainable.
Assalamualaikum and good morning, everyone. My name is Shazifikri bin Sumandi and my matrix number is CD240368. So, I'm going to talk about the problem definition. The focus of our study is the stability and efficiency of trusses, which are vital in structures like bridges, and roofs due to their ability to distribute loads effectively. The challenge lies in accurately determining the forces within each truss member to ensure the structure can withstand applied loads safely. Each member may experience tension or compression, and improper analysis can compromise the stability. Our project addresses this by developing a mathematically model using the method of joint and the method of section. This approach reveals how forces interact within the system and ensures equilibrium, contributing to safer and more efficient engineering design. As you can see, this there are three key steps in the method of joint includes one or first step, identifying joints, which is select a joint where the forces are unknown. Next step, equilibrium equation, which is apply the equilibrium equation to the joint. Sum sum of forces in x direction is summation fx equal to 0, and then sum of forces in y direction, summation fy equal to 0. Next step, solving for forces. Solve the system of equation to find the unknown forces in the connected members. So next, I'm going to talk about the method of section. Alright, as we proceed, one of the effective method for analyzing forces in specific truss members is the method of section. This technique involves cutting through the truss to isolate and examine a particular section. If the entire truss is in equilibrium, then any part of it will be as well. This method especially useful for determining the forces in a few members without having to analyze the entire truss. The key steps include isolating a section by cutting through the truss to focus on the members of interest and applying the equilibrium equation to the section. Next, equilibrium section. Applying the equilibrium section to the section. So it will be sum of forces in the x direction, which is summation fx equal to 0. Next, sum of forces in y direction, and also summation fy equal to 0. Next, sum of moments about a point. Same also, summation of moment equal to 0. By solving this equation, the unknown forces in the chosen members can be determined. The approach assumes that each component experiences either tensile or compressive forces. A hypothesis confirmed through analytical computation. By methodically enforcing equilibrium condition at each joint, it becomes possible to identify the internal forces in the individual elements. A positive compute forces indicates that the member is experiencing tension, while a negative forces value signifies compression. That's all from me. Thank you.
Assalamualaikum dan salam sejahtera. So my name is Muhammad Shazik bin Sofian. My number metric is CD 240362, and I'm going to present to you about a mathematical modeling. As for the problem itself, it talks about we're going to separate the forces in trusses itself. So what I did just now is about horizontal equilibrium and vertical equilibrium, and also I used the MA itself. So by the question itself, it determine the force in each member of the truss, state if the members are in tension or in compression. So as you can see, horizontal equilibrium, Fx equal to 0, and a vertical equilibrium, Fy equal to 0. Alright, so we're moving on to the mathematical modeling, and it shows there that I drew the FBD of trusses, and then as you can see, the dx, which means is minus 450 pounds on the left side, which means it uses the equilibrium of Fx, equal to 0. And then the minus 450 pounds, which means it's the external forces. And then horizontally, as you can see, the Fy equal to 0 would be AB, BC, which means at fit. It is left to the right side, AB to BC. And then as you can see, vertically height would be AD to DC, which means it would be 4 feet. And is with what is the height of the vertical horizontal side. And then the for the reaction forces at supports air and sea. So we're going to use the equilibrium of Fx equal to 0, which means Ax plus Cx minus 450 to get the A and C. And then you just point out the calculations at 450 to the right side, and then X to CX, and then 450 divided by 2, since it's the symmetry, to get the divided side, and then we'll get 225 pounds. Okay, so as you can see, the stated there, since there are no vertical external forces acting on the truss, AY plus XY would be 0 as well. And then since the truss is also symmetrical and no vertical load is applied, AY equal to CY equal to 0. And he stated that's like I told before, by using equivalent Fx equal to 0, we will get the reaction forces at supports so A. As you can see, the FBD of trusses at joint A, as I drew there. And then you can tell that by the joint A itself, it was to analyze the truss using joints to determine forces in each members or points. And then it also by using slope ratio 1, 2, since height is 4 feet and base is 8 feet for inclined members. And then we're going to use the formula of equilibrium Fx equal to 0. And also given that the Ax would be 2 to 5 pounds and to the right side. So it's going to be positive. But in the equation itself, we're going to use FAB minus AX equal to 0, and FAB minus AX will be my FAB equal to minus 2025 pounds equal to 0. And you just point it out to the right side, and then you will get the 225 pounds for FAB would be tensions. And then a formula being used on AX balance the horizontal tension in the member AB. And then since also FID is inclined in the ratio 1 and ratio 2, and we also can determine it as FID equal to 0 so we're moving on to the next one for the joint B. And I also drew the FBD of trusses at joint B. And then as you can tell here, is there is two joint as well we're going to find, which is joint B and joint D. So by the equations, we could get both sides, which is FBC and also FDC. And then at the joint B, at B, members are AB, BC, and BD, which they are connected. And then as the equation of the calculations, if BC minus FAB, which means it would be 0. But as we are trying to find, FFB also has their own values, which mean it would be 2 to 5 pounds. Before we calculated it before. So FBC minus 2 to 5 pounds equal to 0 would be just like the calculation itself. We just point it out the right side, and then you would get the value itself or the forces itself. It would be 2 to 5 pounds, and it also would be tensions. And also does it also BFBD means you're gonna be 0 pounds since there is no forces and there's zero forces. And then also we continue to the joint D. At D, members of trusses AD, BD, and DC are connected. And then the external force 450 pounds acts on the left side, as we see at the first slides. Then we're gonna use the formula of equilibrium Fx would be 0. And then we're just gonna use to 450, which means it's also because it acts on the left side, and then plus FDC, and then just do the calculations, the mathematical equations, and then just point out the right side of the 450 pounds would be on the right side. And then as we can tell, the 450 pounds would be compressions FDC, since it goes to the left side lah. And then AB, and as you can see the table here, the member force and types of the way they go, the way they point out. And then the first member of FAB would be the forces would be 225, and the type would be tensions. And then FBC, and the force would be 225 as well, and it would be the tension as well, which means it would be this way lah, and it's not gonna be this way, or you can see tension or compressions. And then AD and BD would be zero forces, zero force members, and then DC would be 450, which means it would be compressions. That's all. As for the results, and it's easy to hear, the trust analysis revealed the following member forces. AB and BC experiences 225 pounds in tensions, and DC as well experiences 450 pounds in compression, while AB and BD are zero force members. And it also mentions that this result confirmed that the trust is indeed in equilibrium, efficiently distributing loads. The inclusion of zero force members enhances stability under various conditions, and also demonstrating the robustness of the design. By the findings aligned with the safety principles, it showcases how forces are balanced to maintain structural integrity. And that is all about the results. And also the previous one should be about the calculation and how do we get the result itself.
My name is Marcellinus Digat Anasuki. My matrix number CD240335. For this session, during the analysis, we face a challenge like simplify assumption that don't fully reflect real world conditions using computational tools and realistic factors that can improving accuracy. Just a vector or efficient force distribution in a structure like a bridge and a roof. This study highlights the importance of a zero force member and for stability and emphasizes designing resilient structure that can handle dynamic load and a natural disaster.
Conclusion. Hello and Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Syami Azri bin Shadiri, number matrix CD240365. To wrap up, let's summarize the critical techniques for analyzing truss structure, which play fundamental role in many engineering applications. In this presentation, we explore two primary methods in detail, the method of joint and the method of sections. The method of joint involves analyzing the individual components or joints within the truss structure. This approach helps us calculate the acting force and ensures that the structure is in a state of equilibrium. It provides a direct and systematic way of examining each connection on the truss. On the other hand, the method of section takes a more strategic approach by dividing the truss into two sections and analyze one half at a time. Engineers can determine the force acting on those sections. This method is especially useful in large trusses where some part might be failing while the other remains stable. It allows engineers to pinpoint exactly where the stress is concentrated and identify weak point in the structure. By mastering these two techniques, engineer can design and troubleshoot truss structure more effectively, ensuring safety and stability in their application. Okay, we go to the next slide to reference. To conclude, I would like to acknowledge the source that provide valuable information for this presentation. These reference were instrumental in understanding and explaining the concept of truth analysis. The first one, we take it from Baker and Haynes 2024, and second, library text. Third, RC Hybrid textbook, Ford Copeland, Chris and Hansen, 5 Priority 2022. And the last one we take from YouTube and engineer video on trusses of the method joint supplement the technical aspect with visual examples. I encourage you to explore these results for a deeper understanding of trust analysis. Thank you for your
To
attention.
conclude, this presentation has highlighted the challenge and a solution in analyzing structural systems, emphasizing the importance of an efficient design like a truss in a various engineering applications. By integrating realistic factors and an advanced tool, we can create resilient structure capable of withstanding dynamic force and natural disaster. So thank you for your time and attention.